Deploying a machine learning model is a critical step in the machine learning lifecycle. It involves making the trained model available for use in a production environment where it can make predictions on new data. This process ensures that the model can be accessed by end users or other systems, providing real-time or batch predictions. In this presentation, we will delve into the specifics of deploying a model to a batch endpoint, a method particularly useful for handling large volumes of data at once. Batch endpoints are designed to handle large-scale data processing tasks. Unlike real-time endpoints, which process individual requests as they come in, batch endpoints process data in bulk. This approach is beneficial when dealing with large data sets that need to be processed periodically. Batch endpoints are often used in scenarios such as generating nightly reports, processing large data sets for analytics, or applying machine learning models to historical data. Batch processing offers several advantages, including efficiency and scalability. By processing data in bulk, batch endpoints can handle large volumes of data more efficiently than real-time processing. This method also allows for better resource management, as tasks can be scheduled during off-peak hours to optimize computational resources. Additionally, batch processing can improve the accuracy of predictions by allowing the model to analyze larger datasets at once, leading to more comprehensive insights. Setting up a batch endpoint involves several steps. First, you need to prepare your model and ensure it is ready for deployment. This includes testing the model to ensure it performs well on new data. Next, you need to choose a platform or service that supports batch processing. Many cloud providers offer services specifically designed for batch processing, such as Azure Batch or AWS Batch. Once you have selected a platform, you can configure the batch endpoint, specifying parameters such as the input data source, output location, and processing schedule. Before deploying your model to a batch endpoint, it is crucial to ensure it is properly prepared. This involves several steps, including validating the model's performance on a validation dataset, optimizing the model for efficiency, and packaging the model in a format suitable for deployment. Common formats include ONNX, PMML, and TensorFlow saved model. Additionally, you should include any necessary dependencies and configuration files to ensure the model runs smoothly in the production environment. Selecting the right platform for deploying your model to a batch endpoint is a critical decision. Factors to consider include the platform's scalability, ease of use, cost, and integration with other tools and services. Popular platforms for batch processing include Azure Batch, AWS Batch, and Google Cloud Dataflow. Each platform offers unique features and capabilities, so it is essential to evaluate them based on your specific requirements and constraints. Configuring a batch endpoint involves setting various parameters to ensure the deployment runs smoothly. Key configurations include specifying the input data source, which could be a cloud storage location or a database, and the output location where the processed data will be stored. You also need to define the processing schedule, determining how frequently the batch jobs will run. Additionally, you may need to configure resource allocation, such as the number of compute instances and memory requirements, to optimize performance. Once your model is deployed to a batch endpoint, it is essential to monitor and manage the batch jobs to ensure they run efficiently. Monitoring involves tracking the performance of the batch jobs, including metrics such as processing time, resource utilization, and error rates. Many platforms provide built-in monitoring tools and dashboards to help you keep track of these metrics. Managing batch jobs also involves handling failures and retries, optimizing resource allocation, and scaling the infrastructure as needed to handle varying workloads. In a batch processing environment, errors are inevitable. It is crucial to have a robust error handling mechanism in place to ensure the reliability of your batch jobs. This includes setting up automated retries for transient errors, logging errors for further analysis, and implementing fallback mechanisms to handle persistent issues. Many batch processing platforms offer built-in error handling features, allowing you to configure retry policies and error notifications to keep you informed of any issues that arise. Optimizing resource allocation is key to ensuring the efficiency and cost-effectiveness of your batch processing jobs. This involves selecting the appropriate compute instances, memory, and storage resources based on the requirements of your model and the size of the data being processed. Many platforms offer auto-scaling features that automatically adjust resource allocation based on the workload, helping you balance performance and cost. Additionally, you can schedule batch jobs during off-peak hours to take advantage of lower resource costs. Scaling batch processing involves adjusting the infrastructure to handle increasing volumes of data and more complex processing tasks. This can be achieved through horizontal scaling, which involves adding more compute instances, or vertical scaling, which involves increasing the resources of existing instances. Many cloud platforms offer auto-scaling capabilities that automatically adjust the infrastructure based on the workload. Effective scaling ensures that your batch jobs run efficiently and can handle growing data volumes without compromising performance. Security is a critical aspect of deploying a model to a batch endpoint. This involves ensuring that the data being processed is protected and that the deployment environment is secure. Key security measures include encrypting data in transit and at rest, implementing access controls to restrict who can access the data and the batch endpoint, and regularly updating and patching the deployment environment to protect against vulnerabilities. Many cloud platforms offer built-in security features to help you secure your batch processing jobs. To illustrate the process of deploying a model to a batch endpoint, let's consider a real-world case study. A retail company wants to use a machine learning model to analyze customer purchase data and generate personalized recommendations. By deploying the model to a batch endpoint, the company can process large volumes of purchase data overnight and update the recommendations daily. This approach allows the company to provide timely and relevant recommendations to customers, enhancing their shopping experience and driving sales. To ensure the success of your batch deployment, it is essential to follow best practices. These include thoroughly testing your model before deployment, monitoring the performance of batch jobs, optimizing resource allocation, and implementing robust error handling mechanisms. Additionally, it is important to regularly update and retrain your model to ensure it continues to perform well as new data becomes available. By following these best practices, you can ensure that your batch deployment runs smoothly and delivers accurate and reliable predictions. Deploying a model to a batch endpoint is a powerful method for handling large-scale data processing tasks. By following the steps outlined in this presentation, you can ensure that your batch deployment is efficient, scalable, and secure. As a next step, consider exploring the specific features and capabilities of different batch processing platforms to find the one that best meets your needs. Additionally, continue to monitor and optimize your batch jobs to ensure they deliver the best possible performance and accuracy.